My name is Stijn van Verdegem. I'm a technical product manager for VMware, specifically for the network and security business unit. Now, before I start, I'll apologize for the slight smell in the room that there might be. It seems to be getting better, or maybe it's just, maybe it's gone, but for me it feels better, so maybe after a couple of minutes you'll get used to it. So today I'll talk about micro-segmentation. So who here in the room is familiar with micro-segmentation? You've all, seems like 70%. Excellent. And who of you works mostly on security? Where's the security folks? Okay, maybe about 20%. How about networking? And infra? Excellent. That's a really good mixture. So my talk is mainly going to be about micro-segmentation and specifically context-aware micro-segmentation. Here's the disclaimer. You've probably already seen this. This says that some of the things I will talk about at VMware, VMworld may cover features that are not currently available or generally available yet. Doesn't really apply to this session, so you don't have to read it. The virtual cloud network. You may have seen this slide before in other NSX sessions, but the virtual cloud network is basically VMware's vision of networking and security everywhere. Nowadays, as you all know, applications and data don't just reside in the on-premise data center, but applications reside in public cloud. Applications are not just virtual machines, but applications could be containers. Applications and data could also reside at the edge. So VMware's vision with the virtual cloud network is to deliver the same networking and security to applications and data wherever they reside. If they reside in the public cloud, on-prem, as a VM, as a container, or even at the edge. So last year, NSX was a single product. What is new this year is that NSX has turned from being a single product into an entire family of products. What used to be called NSX is what is now called NSX Data Center. And NSX Data Center provides networking and security for data center workloads. We also have NSX Cloud. NSX Cloud provides the same networking and the same security for workloads that reside in VMC on AWS, native AWS, and native Azure. App Defense is modern application security, application that is tied directly to the application and enforces known good behavior. Then there's NSX SD-WAN by VeloCloud. VeloCloud is an acquisition, a company we acquired about a year ago that is in the SD-WAN space, which enables us to extend networking and security from the private data center, not just to the public cloud, but also to the branch or to the edge. And then NSX Hybrid Connect provides data center and cloud workload migrations. So if you're in the right session, you're probably realizing that in this session, the focus is going to be on NSX Data Center, and specifically on security, integration, and extensibility of NSX Data Center. So before I talk more about how NSX can provide security in your data center, let me talk a little bit about the challenge. Traditionally, in traditional networking, security was kind of built with the premise that the application is static, that applications don't change much. Basically, your application developers develop a new application, and you as the networking and security team, you build the rules around that application, and those rules are generally tied to the network topology that the application is deployed in. Now, we all know that's no longer the reality. These traditional security models, they're often using hardware-centric firewalls that are using hardware-based switching and routers. Those models can no longer match with the new application development models. So in reality, an application is not static. Once an application is deployed, unfortunately, that application actually does change. As a result of that change happening, your policies have to be rewritten, have to be redefined. And that's something that is really hard to do with traditional hardware-centric security controls. Think, for example, about the need to configure new VLANs, the need to map all these VLANs across your entire network, the need to update your security policies that are written based on 5-tuple IP address-based constructs. So that's one of the challenges with traditional security in the data center. Another challenge with traditional data center security is the level of segmentation. Typically within a data center, you have a certain high level of segmentation. You have a couple of VLANs, for example, for your web tier, your application tier, and your database tier, but there's no segmentation within these tiers. So if you have multiple applications that are deployed here, that are deployed across the web tier, the application tier, and the database tier. These applications here are free to communicate. There is no filtering in between that. That means that an attack can spread laterally between applications without any type of filtering. Also, with traditional segmentation, all of these applications have uncontrolled access to shared services, and users have the same access to all of your applications. That's the traditional network security model in which there is very little segmentation. What is also key about this traditional security model is that your policies are written based on the environment. You write policies based on your VLANs. You use IP addresses in your policies, so your policies aren't tied to the application. That also means when you decommission an application, the policies that you have, your firewall rules that you have, usually remain in place. So what would be the ideal solution to that? The ideal solution would be something called zero trust. In a zero trust model, we only allow the flows that our applications need in order to function. Now, if we want to get to zero trust, what is the first thing that we need to do? Well, first we need to be able to identify what is the actual application that we have deployed, or what is the actual application that we are deploying. So we need to be able to identify those application boundaries. Once we've done that, we need to be able to identify what are the required flows. What traffic needs to come into my web tier? How does my app tier communicate with my application tier? And how does that communicate with the database tier and so on? That's figuring out the flows. That's the second step in getting to a micro-segmentation policy. And then the third step is isolating the application from any of the other applications that you have and actually applying your micro-segmentation policy, your policy that only allows the flows that your application needs. So that could be flows to your shared services, like Active Directory, DNS, and so on, or it could be flows from users coming into the application. And at the same time, you also want to make sure you filter within the application. So here we need to create a policy that allows the web VM for this application to talk to the application tier only using the services or using the ports that it actually needs to communicate on. So that's the ideal scenario. That's how we get to, or that's the zero trust model in the data center. Now, how can NSX help customers get there? Well, NSX provides an abstraction layer. Basically, NSX sits between the workload and the physical network. And NSX, what it offers is the same level of virtualization that server virtualization offers for x86. NSX offers that same level of virtualization for networking and security services. So this also means when you deploy new workloads, when you deploy those new applications, you can create a networking policy and a security policy that is tied to those applications and is completely independent of the underlying physical networking. So, or we also allow decoupling of applications from the infrastructure to the software through the software-defined network and data center and network virtualization. One of the key elements in getting to micro-segmentation is what we call the DFW, or the distributed firewall. For those of you that are familiar with micro-segmentation, you probably know that the DFW sits at the VNIC of every virtual machine. Basically sits between the VNIC of the VM and the distributed switch. And right between that VNIC and the distributed switch, we have what we call I/O chains. I/O chains allow us to insert services, such as the distributed firewall, but also additional security controls. And that's what we call network introspection. And we can, for example, that's what you can see here with the green icon. So the blue icon is the distributed firewall. It sits between the VM and the network. And then after that, we can layer on additional security controls, such as an IPS service or a next-generation firewall service. Now, the distributed firewall, we call it distributed because it's distributed to every hypervisor. It's implemented in kernel, and that allows us to achieve line rate throughput with the distributed firewall. With the current release of NSX 4 vSphere, that's NSX v6.4, we also support layer 7 firewalling. And layer 7 firewalling is one of the aspects that make the distributed firewall, or that allow us to achieve context-aware micro-segmentation, is layer 7 firewalling. Also key with the distributed firewall is when you write your policy, you no longer have to write a policy based on network-based constructs like IP addresses and ports, but instead you can use a policy, or you can write a policy that is related directly to the application. So in your source and destination, you can use a construct called a security group. The security group groups a number of workloads that need a common policy. And I'll talk a lot more about that later. So it's all about creating a policy that is tied directly to that application. Also, vMotion is supported with the distributed firewall. So when a VM vMotions from one host to another host, not only the security policy, but actually the connection table for that particular VM moves right along with the virtual machine itself. Another benefit of the distributed firewall is that the security services scale as you're adding more compute. So when we're adding an additional hypervisor here, we're automatically adding more firewall capacity. Now, of course, if you're managing all of these individual distributed firewalls that are sitting at all of these VNICs, it would be impossible to do that individually. So these are managed through NSX Manager. In NSX for vSphere, the actual UI for that is done through a plugin from vCenter. So from vCenter, and this is showing the HTML5 UI, you configure your distributed firewall policy, and you can create rules here that are based on security groups in the source destination. You can use layer 7 services as your service objects. Another benefit that I mentioned is service insertion, which is the ability to add on additional security controls. I mentioned IPS IDs or next generation firewall. So if the layer 4 through layer 7 filtering that the distributed firewall provides is not sufficient, you can add in an additional IPS, an additional security control through network introspection. What we also do is we share our context-centric network attributes, our security groups that can be based on the virtual machine name. We can have security groups that are based on the operating system, security groups that are based on security tags. We also share these with our partners, like Palo Alto Networks, Fortinet, or Checkpoint. So on your partner management console, where you have your IPS rules or your next generation firewall rules, you can use those same security groups that you have defined inside NSX. So that also allows you to move away from using IP addresses on the partner side. Okay, so the extensibles ecosystem for advanced security controls. So here I'll talk a little bit more about these additional security controls that we can insert. I mentioned already an IPS or next generation firewall. Another use case is called agentless antivirus. What agentless antivirus allows us to do is in environments like VDI, where you have a very high consolidation ratio, you have a lot of VMs on a single host, and a lot of these VMs traditionally need an antivirus agent. Now, one of the challenges with that is that these agents all need to run, all need to perform scanning tasks, all eat up a lot of resources. And that's why we have a function called guest introspection, which allows us to offload that scanning functionality to a specialized partner service VM, of which you deploy just one on a particular host, and that enables you to remove that particular AV agent from all of the individual guest VMs. So that's agentless antivirus. You can also be very selective with these services that you apply. So on a per VM basis, you can choose which VM, which workload, which application needs what particular service. Data that is more sensitive, for example, may need additional controls, while data that is not as sensitive may not need an IPS or an antivirus, for example. What we can also do is security tagging. For example, if your next generation firewall or your vulnerability scanner finds a vulnerability on a certain workload, it can apply a security tag to that workload. Based on that security tag being applied, the workload then becomes a member of a security group, and as a result of that, we can add on an additional security control. We can, for example, force that traffic to dynamically go through an IPS service. So that's what we call the service insertion framework with NSX. This kind of shows an overview of all the different partners that we support here. So, I mentioned a couple of them already from the service insertion side, but you see that it's really a very broad ecosystem that does not just include security. Now, as I mentioned, one of the key benefits of using NSX is that you can write a policy that's centric to the application, that is not network-centric. But there's basically 3 types of policies that you can use when you define your firewall policy. A network-based policy means that you use IP addresses, MAC addresses in your firewall policy. Challenge with that, it's different, it's difficult to operate, it's difficult to change, and it's not tied to your application. So that often results in having a massive amount of rules on your firewall and nobody really knowing what those rules are for anymore. So that's a network-centric model. Then kind of in the middle is the infrastructure-centric model. This means that you write your firewall policies based on network constructs like a logical switch or a distributed port group. You use that as your source destination. So you're a little bit closer to the application, but it's still not quite tied to the application directly as well. In an application-based policy model, your policy is not tied to the physical or logical topologies. Instead, you make tailor-made policies that are specific to individual applications. You create a policy and you tie that to the application. That also means when you decommission the application, the policy is removed right along with the application itself. So the goal is really to enable customers to move that to that application-centric policy model. Now, how do you actually write your policy in NSX? There's two different options. You can either use the firewall rule table or you can use Service Composer. The firewall rule table, if, for the security guys, if you're used to a regular firewall, this is going to be the most similar. So that's what you can see on the left here. You can see the different firewall rules. You can have different sections to group rules in. And this kind of shows a very common policy model here in which rules are organized in different sections with an emergency rule section on top, which customers use to put quarantine rules in, for example. Then there's the infrastructure rules, which define access to shared services like Active Directory, DNS, and so on. And then below that, we have the intra-application rules, the actual micro-segmentation rules that dictate how traffic can flow between applications and between the application tiers. And of course, in a zero trust model, the goal is that we can change that default layer 3 rule that is in that section from a default allow into a default deny. That's the very goal. So in order to do that, we need to create very specific allow policies. They're a whitelisting model. The other way of writing your micro-segmentation policy is Service Composer. And Service Composer provides a higher level of abstraction. With Service Composer, you can create a security policy and apply that one security policy to multiple security groups. So it's basically like a template. So that obviously gives you a lot more flexibility. You write a policy once, and then you apply that policy to all of the applications that need to have access to shared services, for example. So a little bit more about security groups. Security groups provide contextual grouping of workloads and services. They basically group a number of workloads based on certain conditions. You can statically include virtual machines in a security group, or inclusion can be dynamic based on certain criteria. These criteria can include the operating system. And a use case for that is, for example, you may have workloads that are running a version of Windows that is no longer supported by Microsoft. And obviously, you want to restrict. You want a more restrictive policy around those workloads. So because we tie in with vCenter and we exchange the inventory between NSX Manager and vCenter, we can automatically determine the operating system of any guest running in your environment, and we can create a security group that matches a particular operating system, Windows 2013, whatever it is. And then based on that, we can apply a more restrictive security policy. Other potential criteria for dynamic inclusion is machine name. If you have a really well-defined naming convention for your virtual machines, you can define your security group membership based on machine name. For example, prod-web for any machine that is deployed in production and is deployed in a web tier. That's just an example there. Security tags, I'll talk a lot more about that later. Security tags are a very dynamic way of grouping workloads into a security group. And security tags can be based on a lot of different criteria. And then user or VDI, so in VDI environments, we can provide security controls, access to applications based on the individual user. For example, so that an HR user is able to access the HR application, a finance user is only able to access finance applications. And we do that by tying into Active Directory, and that then allows us to create a security group in NSX that is based on an Active Directory group. And we can then tie that particular Active Directory group to a policy in NSX. And then what is new in NSX 6.4 as well, along with layer 7 support, and I'll focus on that in my session as well, is user session support, specifically for RDSH. If you have multiple users that log into the same RDSH host, the same RDSH host, then we can still differentiate between these different users. And we do that by what we call context-aware firewalling. We basically are able to tie that user to the specific SID, the SID of that user, and we implement that SID directly for enforcement on the data plane. So we can create rules based on the Active Directory group, and even if these two users log into the same RDSH host, we're able to differentiate between those two different users that belong to different Active Directory groups and apply a specific policy to these users. That's what we call identity firewalling for individual users with VDI and multiple user session identity firewalling for RDSH. Now, security tags, as I mentioned, security tags can be applied to a virtual machine dynamically. They can be applied to a virtual machine when the VM is being provisioned. For example, through a VRA, in your blueprint, you can apply a particular security tag to a virtual machine. And these tags are widely used by your customers. When I joined VMware 3 years ago, this was not used a whole lot yet. A lot of customers were statically putting virtual machines in security groups, but these security tags have become very widely used. So security tags are used commonly to, for example, describe the function of a virtual machine. For example, this is an Apache server, or the application tier. This is a database tier, or the security posture. And we also integrate with third-party partners. For example, Forescout Counteract. If they detect that a certain virtual machine is out of compliance, they can apply a security tag to that virtual machine that identifies the VM is out of compliance. And then because of that, a more restrictive security policy is applied to the virtual machine. So that's a security tag based on security posture, regulatory requirements, for example, PCI, or the environment. Is this VM deployed in production? Is it deployed in development? All of these are just a couple of examples of how security tags can be used to identify particular criteria about a virtual machine. So here's an example. We have a VM, and there's a couple of security tags to identify that this VM is a database VM. It's part of an SAP application, and it needs to be GDPR compliant. And then based on the resulting security group, based on these security tags being applied, a security policy is automatically compiled for that virtual machine. Now, contextual services, as I mentioned, your service objects can either be based on layer 4, meaning you allow or you deny traffic between workloads based on a particular port. They can also be based on layer 7, as of NSX 6.4. So yeah, you have your layer 7, your layer 4 port-based services, layer 7 services that can be port independent, so you can choose to allow MySQL to your database VM regardless of the port that a server is actually running on. You can also use a combination of port and layer 7 service. And then you can also group multiple services into what we call a service group. So a little bit more about layer 7. Layer 7 firewalling, we've introduced this in NSX 6.4. It provides port-independent identification and enforcement on the distributed firewall. And the focus of the layer 7 inside the distributed firewall is really on east-to-west traffic and enterprise applications within the data center. There's about 70 built-in layer 7 service objects, things like Active Directory, also things like DHCP or HTTPS, and different TLS versions. But it's really focused on traffic that is commonly seen within the data center east to west. So unlike a traditional perimeter firewall, where you have a next generation firewall that has over 3,000 app IDs and that has application IDs such as Facebook and things like that, our focus is not like that. So we have about 70 application IDs really focused on traffic that we commonly see within the data center. And these layer 7 service objects can be used in firewall rules. They can also be used in flow monitoring and application rule manager. I'll talk more about this flow monitoring and application rule manager, or what we call ARM, later in the session today. So the benefits of using layer 7 service objects is that you get enhanced visibility into east to west flows. We don't just identify the port that a service is running on, but we actually fingerprint the application. We fingerprint the protocol that generated that flow. We also reduce the attack surface by, instead of opening an entire port, we're only allowing a particular service, like a specific TLS version, to traverse port 443. And another key benefit is that it doesn't have any impact on throughput. And I'll cover the architecture in one of the next slides to make clear why that is. Okay, so here are some of the use cases of layer 7 firewalling on the distributed firewall. So I already mentioned most of these. Enforcement based both on port and layer 7 app ID, blocking of vulnerable application versions. You may want to block specific versions of SSL or TLS, and you can do that using layer 7 based policies. Port independent application enforcement. For example, you want to allow MySQL, but you're not really sure what particular port that your developer has their MySQL service on. So that allows you to create a service, to create a firewall rule that just allows MySQL, regardless of the port the service is actually listening on. And the last one is layer 7 visibility. So if you want to identify what traffic actually traverses a particular port on a workload, we provide that visibility as well. So a little bit more on controlling application protocol versions. So this is enforcing the use of more secure or less vulnerable versions of an application or a protocol. This is something that could be applied to individual applications. When you create your micro-segmentation policy for a particular application, for that application you could enforce the use of TLS 1.2, for example, or you could also use that in a global, in a kind of a global guardrail rule, in which you say that any traffic that comes into my SDDC, no matter what the application is, any TLS version 1.1 or 1.0 traffic should not be allowed. That's kind of the use of a layer 7 version-based object in a guardrail rule. So currently for version-based enforcement, we only support SSL and TLS in NSX for vSphere. But this kind of shows the use case. So we're creating a policy that only allows TLS version 1.2. Any TLS 1.1 or 1.0 traffic would be blocked by default. And here's an example of that as well. So let me talk a little bit about the architecture, how we've implemented layer 7 firewall in the distributed firewall. So what you're looking at here, the big box, that's an ESXi host. And on top of that, you have your management components, NSX Manager, vCenter, and optionally you could have your third-party manager, for example, your Fortinet or your Palo Alto management solution. We also have an Active Directory server, which we use for our RDSH or user session identity firewalling. So let's look at a packet here that leaves one of the guest VMs and enters the distributed firewall filter. First thing that happens when a packet enters the distributed firewall filter is in kernel, we need to see if this packet belongs to an existing flow. We need to check the flow table. And let's say that in this example, there's no entry in the flow table. In that case, the next step is that we need to check the rule table. Do we have an existing entry for this particular flow? If the answer is yes, there is an existing rule that matches the flow based on the 5-tuple, based on the source and destination IP and port, and that particular rule has a layer 7 service object. If that's the case, then we will program a flow entry in the flow table, and that flow entry will have an action set to punt. That means that any packet that belongs to this flow is going to be punted to the user space, to what we call the DPI engine, or the deep packet inspection engine. So this packet now gets punted to the DPI engine, and the DPI engine, the responsibility of the DPI engine is to determine what is the app ID. What is the actual application, the actual protocol that generated this particular packet? Now, the really good thing about this implementation is that it typically only takes 4 packets per flow to determine the app ID. So that means there's only 4 packets that we need to send up to the DPI engine in user space. All the other packets are processed in kernel. And that's why there's no performance impact of using layer 7 in the distributed firewall. So the DPI engine will now try to determine the app ID. Once it has determined the app ID, it programs an entry in the context table that basically identifies that this flow has been determined to be TLS version 1.2. And now the next packet that comes in for this flow, we basically just compare the entry that we have in the context table again with our rule table. So now we've determined this flow is TLS version 1.2, and our rule says allow TLS version 1.2. And then based on that, we update our flow table entry, and any subsequent packet for this flow is just going to be matched against the flow table. All we do at this moment is checking the state. Is the state for this packet valid? Should it be allowed based on this particular flow? So the vast majority of packets are processed in kernel. Only 4, up to a maximum of 10 packets, are redirected to the DPI engine to determine the layer 7 app ID. I'll cover this in a demo, but this kind of shows how to create a new app ID. There's built-in layer 7 services that are port independent. If you want to create a port object that is based, a new service object that is based on port and app ID, you can add a new service that specifies both the layer 7 app ID as well as the port that service should be allowed on. And then you can use that service object in your distributed firewall rules. So you'll see this diagram a couple of times for the remainder of the session today. But this basically shows an architecture that I'll be using for a few of the demos. It's pretty simple. We have shared services here on the left, an Active Directory, DNS, and NTP. And then there's two applications that we've deployed. There's an MRS, a medical record system application, and there's an HRM, an HR management application. These are real applications. They're not demo applications that we've built. They're real applications that our customers are deploying. And the goal is going to be, in this first example, to micro-segment these applications. Actually, initially, what we want to do is using security tags and using layer 7 service objects, we want to be able to isolate the MRS application from the HRM application. And let's have a look at how we can do that. The first thing that we can do is we can apply security tags to our different VMs. So we apply a security tag to shared services, to our shared service VMs. We apply a green security tag to all of the VMs that make up the MRS application. And we apply a blue security tag to all of the VMs that make up the HRM application. And then, as a result of these security tags being applied to these virtual machines, all of these VMs become a member of a respective security group. So the VMs with the green security group match the inclusion criteria for the MRS security group. So these automatically become a member of the MRS security group. The VMs with the blue security tag match the condition for the HRM security group and become a member of that security group. Another benefit of using security tags is if your application needs to scale up, if you need to add on an additional web tier, for example, and you add a new security tag to that web tier through your blueprint or when you're deploying the VM, that VM will automatically become a member of the HRM security group. So that doesn't require any manual interaction. Same would be true if you remove a virtual machine from an application, it will automatically be removed from the security group as well. So now in order to isolate these two applications from each other, we need to create a security policy that does that, and we can do that using just 3 policies. One policy that we call the shared services policy. This policy is basically going to allow the application to communicate with shared services. And if you look at that role, you can see that the destination is the shared services security group. In service, we're using Active Directory, DNS, and NTP. These services are being allowed, and they're identified based on layer 7, by the way. And the action is set to allow. The source here is set to PSG. PSG stands for Policy Security Group. It's basically a template. That means that when we apply this policy to different security groups, the source PSG object will be replaced with the actual security group that you apply the policy to. So that enables us to create a policy, create it once, and apply that policy to multiple security groups. So that's one security there for shared services. We have another policy for intra-application, which is an allow policy that basically allows any communication within the application. And then I've created a third policy, which is an inter-application default policy. And the inter-application default policy does the opposite. It blocks all the communication between different applications. And then all we have to do in order to segment the MRS application from the HRM application, but at the same time make sure that both of these applications can access our shared services, all we have to do is apply these 3 security policies to the MRS security group and apply them also to the HRM security group. So that's isolating the applications from each other. That's not quite micro-segmentation yet, because the next level is how do we actually segment? How do we create a policy that only allows our web tier virtual machines to talk to the application tier and the application tier to the database tier using the service or using the port that they're communicating on and blocking all other traffic. But in this case, as I mentioned, the HRM application is able to access shared services. MRS is able to access shared services. Any traffic between the applications is being blocked by the default inter-application policy. Now let's look at the next example, and this is actually micro-segmentation within the application itself. So in order to do that, in order to only allow the flows within the MRS application that the MRS application needs to work, we need to understand what those flows are. And we also need to understand how to do our grouping. So we can create a couple of additional groups here. I created a group for MRS Web that matches a purple security tag, one from MRS App, and one for MRS Database. And then I've applied additional tags to my workload. I've applied the purple tag to my web VMs, applied the orange tag to the app VM, and applied the red tag to the database VM. Now again, as a result of the tags being applied, these VMs here become automatically a member of the respective security group. And now we can apply a micro-segmentation policy that is only going to allow the flows that the application needs to work. So in this case, for the web tier policy that is applied to the purple security group there, I created a policy that only allows HTTPS TLS version 1.2. For the app tier policy that is applied to our one app VM, I created a policy that allows HTTP from the web tier, and it also redirects this traffic to a partner service IPS. And then finally, I've created a third policy that is applied to the database tier security group, and this policy applies or allows only MySQL on any port, only from the application security group into the database security group. So this is how we can micro-segment within the application itself. So now let me give you a demo using based on the same setup. So here, we're applying the policy first, and as a result, it's going to show us the result again. As a result of this policy being applied to these security groups, we allow HTTPS TLS version 1.2 inbound to our web tier. We allow HTTP from the web tier to the application tier, and MySQL from app to DB. And in this example, in this demo, I'm using the exact same application that you just looked at. So I've defined a couple of security groups. Let me start the demo here. So I've defined a couple of security groups, and let me filter here on MRS. We're looking at the MRS application. These are security tags, and I've applied these security tags to the VMs that make up my application. There's 4 VMs in the MRS application in total. These all have an MRS tag. And then the MRS web tag has been applied to our 2 web VMs. From there, I can go to Service Composer and go to the security groups. And here we have 4 security groups. There's the MRS web security group. The security group is based on that security tag, the MRS web security tag, being applied to a virtual machine. So that's what you saw in the diagram earlier as well. Now, we can look at the security policies that are applied. There's 2 security policies applied to the MRS security group. The shared services policy that allows access to shared services, and then the inter-application default policy that basically blocks communication to other applications. And those result in 3 firewall rules, the shared access rule, and then the rules that block communication to the other applications. Now, when we look at the MRS app security group, we can see there's 1 policy applied here. We call it the MRS app tier policy. That policy has 1 firewall rule, the application tier access policy, and we'll look at that policy in more detail later. And also has a network introspection policy, which redirects this traffic to a partner IPS service. Now let's have a look at this policy in a bit more detail. So I go to security policies. I go to the MRS app tier policy. And here we can have a look at the firewall rules, and these are the same rules that you saw earlier in the diagram. So there's the MRS tier access rule that allows traffic from the web tier to the application here, only using HTTP traffic. You can also enable logging and configure the rest of the rule here through Service Composer. And at the same time, we also have a network introspection rule, which redirects the same traffic to a partner next generation firewall to apply IPS service. So that's how you configure a security policy through Service Composer. And again, a key thing is that you can define a security policy once and then apply it to multiple applications that need the same policy. This view is the firewall rule table. And here you can see whatever you configure via the Service Composer actually gets configured into the firewall rule table automatically as well. So you can review your policy here. And we can have a look at statistics by clicking on the little statistics icon. That's going to tell us the hit count, rule stats, the amount of packets, the amount of traffic that has matched this particular rule. Once we've done that, we can verify that our OpenMRS application is actually working. So we're quickly checking the database here. We're exercising our application. And then as a result of that, we should see that our rule counters for all of the micro-segmentation rules have increased. So that's doing micro-segmentation. We've segmented the applications from each other, and we've micro-segmented the OpenMRS application. We can also look at live flow monitoring to identify the rule that is being matched and identify the HTTPS traffic. Now, in this case, I've changed the TLS version from 1.2 to 1.0. Remember, our rule only allows TLS 1.2. So as a result of that, our application is no longer working. And this time when we look at live flow monitoring, we can see that the traffic is now matching rule 1 to 80, and that traffic has been identified at TLS version 1.0. When we look at rule 1280, we can see that's the default block rule from the inter-application default policy. So that traffic, the TLS 1.2 traffic or 1.0 traffic, is being blocked because of our default inter-application default policy. Okay, so now one of the most common questions that I get when I talk about microsegmentation is how do I actually start? How do I microsegment my application? A challenge with any kind of zero trust model is that you need to understand the flows that your application needs in order to work. Now, you could look at product documentation, you could talk to your application team, but in reality, documentation is often poorly written, even for off-the-shelf applications, it's often very incomplete. It doesn't really show all the ports that need to be opened up, and even the applications teams often really don't know that. So, using these resources often is not quite enough. So, we at VMware, we've really focused on making microsegmentation easier, making it easier to understand the flows that an application needs and get to the right role set. One of the options to do that is what we call vRealize Network Insight, or VNNI. And VNNI is able to collect all the flows within your environment as long as you have a distributed switch. It's based on IPFix, and then based on those flows that are collected, it can automatically give you the whitelisting policy that you need for each of your applications. And that is only one small aspect of what VNNI does. It's called microsegmentation planning. VNNI does a lot of other things. It provides visibility across virtual and physical. It provides compliance monitoring and quite a lot of other things. There are too much to go into detail in this session. Another option that we have is built right into NSX. And this was introduced into NSX for vSphere 6.3. It's called ARM, or Application Rule Manager. So the goal of ARM is, again, to help you to get to a micro-segmented application. What you do with ARM is you start basically by selecting the VMs, the workloads that make up your application. Then ARM will collect the flows, it will analyze the flows, it's going to deduplicate flows, it's going to use an ALG to stitch together the control channel with data channel of an application. And it's going to, in the end, give you, these are the list of rules that you need to micro-segment this application. These are the whitelisting rules. If you implement these rules, your application is still going to work, but any other flow that is not that the application doesn't need will be denied by default. That's the goal of Application Rule Manager. So I'll give you a quick demo of Application Rule Manager as well. So remember, in this case, we already have micro-segmented the medical record system application, but we still have our HR, or HR management application. We have isolated the HR application from the MRS application, but within the HR application, there is no micro-segmentation yet. So we're going to use ARM, and we're going to focus on this HR management application. ARM is going to profile the application, and that is going to help us to identify what are the specific rules that I need to micro-segment also this HRM application. So here's the demo. This shows Application Rule Manager, or ARM. ARM can monitor multiple applications at the same time, up to 10 sessions at the same time, and we can collect up to 2 million flows at the same time as well. So these are a couple of applications, a couple of existing ARM sessions that were running before. What we're going to do in this demo now is I'm going to start a new ARM session. And as I mentioned, we can collect up to 2 million flows. That's in 6.4. That's in our latest release. We've significantly improved the scale of Application Rule Manager. First thing that we have to do is we create a new session, give it a name, and we select all of the VMs that make up the application. So remember, from the diagram, there was 2 web tiers, an app tier, and a database tier. Select all of these VMs. And as soon as we do that, ARM is going to start the collection process. Right at the distributed firewall filter, at the VNIC of every VM, we collect all the flows that come in or that leave, and we display the flows. That's called the collection phase. Once we've collected all the flows, we can stop the collection process. And then we can click Analyze to analyze the flows. What Analyze is going to do, it's going to translate IP addresses that you see there into virtual machines, and it's going to apply deduplication. It's going to use an ALG, and it's going to use the L7 app ID to resolve the actual application, to resolve the layer 7 service in between different flows. What it also does, and that's even more important, is rule planning. So with Application Rule Manager, we're automatically going to get the recommended rules that you need to micro-segment this application. So in this case, you see the rule to allow load balancing traffic to the web tier, second rule is to the app tier, and the third tier is to the database tier. We also automatically group VMs into security groups. You can see that we grouped our web VM1 and web VM2 in a particular security group. And we identify traffic not just based on port, but also based on the layer 7 app ID inside of the application rule manager feature. So here on the second rule, this is the rule from the web tier to the application tier. And the third rule below that is the rule from the application tier to the database tier. You can see that we've identified traffic incoming to the web tier is based on HTTPS TLS 102. Then traffic from the web tier to the app tier is HTTP. And traffic from web to database is MySQL. We also see a fourth flow here. And we're not exactly sure what this flow is. We've identified it as being CIFS. So then what we can do is we can go back into the flows overview to get a little bit more background on why did NSX automatically recommend these rules. So this is going to show the analyzed flows that were the basis for these automatically generated rules. And here we can see the flow that resulted in the last rule that we just signed, the firewall rule table. Now, the only rules that we will see in rule planning, the only rules that will be automatically recommended are rules that don't exist yet. Traffic that matches an existing rule, like this traffic, match the shared services rule. For that, we're not going to automatically recommend a new rule because the rule is already in place. So only new rules that are not existing yet, only those will be recommended here in the firewall, in the recommended rules table. Now, you could publish these directly to the firewall rule table. Obviously, you don't want to do that. So in this case, that last rule that we had there for CIFS, we don't want to allow that. We don't want to create a rule for that. So we can remove it. We can do additional tuning. We can rename these security groups to something that makes more sense than the default of NSX recommended security groups. So I call it HRM Web. And we can also rename the firewall rule names to something that is a little bit more relevant to the way that we want it. So, key thing here is this allows you to do auditing before you publish these rules directly to the firewall rule table. Now, once we've completed our auditing, we can publish the rules to the firewall rule table, give it a name, and this is going to publish these rules as a section into the firewall rule table. And we can choose where to insert this into the firewall rule table. And once publishing is done, we can go back to our firewall rule table and confirm that the rules have been applied there. You can see the HRM section, and you can see these are the 3 rules that were automatically recommended by the application rule manager. Now we can enable logging, for example, or we can make any additional changes that we want to do here. And we can again confirm now that this time our HRM application is working as intended. And then again, once our application is working, we can go back to the firewall rule table and actually confirm that the rules are matching the traffic by looking at the rule stats. Okay, so that's 2 ways of doing micro-segmentation. We micro-segmented the MRS application manually, and we micro-segmented the HRM application automatically using the recommended rules and recommended security groups from application rule manager. Now let me talk about the last aspect of my session here, which is user session-based identity firewall. If you're familiar with NSX for vSphere, we've had the identity firewall feature for quite a while. And with the identity firewall feature, we were able to apply a differentiated policy to a different set of users. This was mainly intended for VDI, but didn't support RDSH. So the difference between RDSH and VDI is in RDSH, you have multiple users that log into the same host. So in order for us to differentiate between these different users, we basically leverage the same context table that you looked at when I showed the layer 7 architecture. We leverage that same context table to keep track of different users, to keep track of the SID of each user. So that allows us to, in this case, you can see there's an Alice in the HR group, Bob is in finance, and we have 2 different rules here. We have a rule that allows finance users access to the finance applications. There's another rule that blocks access to the finance applications for any other user. So these rules are based and they're implemented. The enforcement on the data plane is based on the SID of each of these Active Directory groups. We sync up at Active Directory, NSX Manager gets the SID for each Active Directory group, and it programs that SID directly into the data plane. Then when a new flow comes in from our RDSH host, that flow is basically tagged with the SID of that Active Directory group, and it's matched against the rule table entry. So again, looking at our existing setup here, I've added a couple of additional things. I've added an RDSH pool, and I've also added a couple of users here, Bob and Alice. And Bob and Alice are part of a different set of users, a different Active Directory group. Alice is part of the medical staff. She's a doctor. And Bob is part of the HR staff. Now, as I mentioned, we sync up with Active Directory, and for each of these AD groups, we resolve the SID of the group. Now, I've created a couple of policies. I've created a medical staff policy. The medical staff policy has two rules. The first rule on top there basically allows traffic to the load balancer for the MRS application. The second rule blocks traffic to all of the other application VIPs. And then I've also created a policy for the HR staff policy, which is basically the exact opposite. The HR staff policy allows traffic to the load balancer or the VIP for the HRM application, and it blocks access to all the other VIPs for all the other applications. So that's only two different policies that we have. Next thing we have to do is apply these policies to our security groups. So we apply the medical staff policy to our medical staff security group. We apply the HR staff policy to the HR staff security group. And now let's have a look at what actually happens when these users log into an RDSH host. You see Alice is logging in here to an RDSH host. Bob connects as well, and he's landing on the same RDSH host. Now, as a result of these policies being realized on our data plane, or Alice, Dr. Alice is able to access the medical application. Bob is able to access the HR application. However, when Alice tries to access HR, that's not allowed because of the second rule in the policy. Similar, when Bob tries to access the medical records application, that's also being denied because of the block rule in the HR policy. So that's user session identity firewall, and let me show you a quick demo of how that is actually done as well. So we're again looking at NSX for vSphere here, and we're going to have a look at the security groups that are based on Active Directory group this time. So we go to Service Composer, and then we go to our security groups. And let's have a look at the two different security groups that we have here based on the HR Active Directory group. You can look at the objects to include, and you can see that this inclusion is based on HR staff, which is a directory group. So we tie into Active Directory, and we get visibility into the different Active Directory groups. So in this case, we've selected the HR staff AD group. The medical staff security group is based on the medical staff Active Directory group. And we've applied a couple of policies. The HR staff policy is applied to the HR staff security group, and the medical staff policy has the medical staff policy applied to it. So similar to what we saw with all the other policies. Now let's have a look at the actual policies that we have. So there's the medical staff policy and the HR staff policy. Let's open up the medical staff policy and have a look at the firewall rules. Basically two rules in here. One rule that allows access to the load balancer VIP for the HRM application, and the other secondary rule that denies any traffic to any other applications. We've enabled user identity at source, but basically tells NSX to realize this rule on the data plane based on the SID of these Active Directory groups. Now let's have a look at the firewall rule table. Again, any rule that you configure through Service Composer also gets configured automatically in Service Composer. And you can see that we've created two sections here, and you can see the different rules there for the HR policy and for the medical staff policy. Now we're looking at the actual hypervisor. This is how the rules look on the data plane. And you can see that in the data plane, in the rules, we actually have we reference the SID for the different users. This particular SID here is the medical staff SID. And then the second SID that you see, the second SID there, which is used in the last two rules, that one is referencing the HR staff. So, that's really a very important thing to get. We're not translating or we're not implementing rules based on IP address, but actually based on the SID of the user. So now let's say that our user Alice logs in from her iPad and connects to her RDSH session. This could be VDI as well, by the way. I'm just showing RDSH to show that this different policy is applied, although different users connect to the same RDSH host. And she opens up her medical record system application. Now, she's seeing a patient today, so she's opening the patient records. She's a doctor, and it looks like her patient is missing an eye. So, she's performing surgery on her patient. and she's saving that record of what she's doing there. She's replacing the missing eye, she's saving the record. Now, Alice thinks that she's done a really good job, so she thinks she needs a raise. So she tries to access the HR application, the HRM application, but that's being denied because the policy only allows the HR users to access the HR application. Now our HR user, Bob, accesses his RDSH session as well. He's landing on the same RDSH host, so connecting to the exact same host that Alice was, but he will get a different policy applied. So he's connecting to his desktop here, he opens up his browser, and he's trying to access the HR application. Now, he is able to access it, unlike Alice. And because our doctor or HR person believes that Dr. Alice did such a good job, he agrees that she needs a raise, so he goes up to the salary information here in the HR tool, finds our user Alice, and gives her a raise right in the system here. So that's the user session identity firewall. We supported this for VDI for quite a while, since NSX 6.3, but support for RDSH, multiple users on the same session host, is new in NSX 6.4. And then also we can see visibility here when we go back to our firewall rule table. We can see that Bob became a member of the HR security staff because Bob logged in with Bob logged into this particular RDSH host. And that concludes the session. So thank you all for your attention.